So in this video, I'm going to show you how to simplify roots. Very simple simplifications, nothing too complex. Because yeah. So I'm just going to show you how to simplify roots. And what I mean by that is, if you had something like, let's say, 27, square root of 27. Okay. So the square root of 27 is going to be some number that you don't know, unless you have a calculator or you do it by hand. So the square root of 27 on this calculator, it's saying that it's 5.1961, blah, 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 whatever. You're not going to know that, right? You only know the simpler roots, like let's say you had the square root of 9, right? That'd be 3, right? Because 3 times 3 is 9, right? Or you know that 16, square root of 16, right? It's just 4. 4 times 4 is equal to 16, right? So one way you can simplify something like the square root of 27 is you can, on the inside of the square root, you can rewrite it as 9 times 3, right? Right, because 9 times 3 is just 27, right? I just rewrote it this way. And what you can see is that you have a 9 and a 3, right? But you already know the square root of 9, right? And when you have multiplication like this, if it was addition, like let's say we had 9 plus 3, you can't do what I'm about to do right here. You can't do it. What I'm going to do up here is I'm going to split the square root symbol to each of these numbers. So square root of 9, square root of 3. If I was adding, you can't do that. Okay, this is not the same as. I just want to make this clear because some people get it confused. So this and this are not the same thing. We're multiplying. You can only do this with multiplication. You can only split the square root between these two numbers when it's multiplication. You can't do it with addition. So once we're here, you just take the square root of 9, which is 3, right? And you could just leave it the square root of 3 like that, and that's your simplification of square root of 27. That's just a simplified way to write it. Another example would be, let's say we have square root of, let's say, square root of 50. Square root of 50. You want to find a number that can be square rooted, basically. You want to split this into two numbers, and hopefully one of those numbers that you split this number into is a square root, perfect square. That's what they're called, a perfect square. So if you know quarters, this should be a little easy. If you know how much a quarter is 25 cents, right? And if we have 2 quarters, we'd have 50, right? So 2 25 cents would give us 50, right? It's 2 quarters, right? So we can have 25 times 2, right? Split them up. 25, square root of 25 times square root of 2. Square root of 25 is 5, right? And this is your simplified version of square root of 50. So yeah, that's basically the whole gist of this. You just gotta find, hopefully you can find a number that, can split up into some other number that you can find the square root of. Basically, it takes a little intuition, but once you get the hang of it, it should be pretty easy. Now, the next thing I want to talk about is adding square roots and subtracting square roots. So if we had something like this, we can treat these square roots, right, as variables, right? So if let's say I had 3x minus 2x, right? Hopefully you know that when you do something like this, you're just left with x, right? Or 1x if you want to write the 1 there, right? Right? Because 3x minus 2x is just 1x, right? So you can kind of like, in this sense, you can also see these as variables. So you're just going to be left with 1 and then square root of 5. So your square roots have to be exactly the same. This has to be the exact same like number in the inside for you to subtract it, basically. Same thing goes for addition. Let's say you're adding something like this. These have to be the same. And the answer to this is 13. Right? So that's how you do something like this. Same for addition and subtraction. But these have to be the same. If you have something that's different in the square roots, so you had 27 here, right? You can't just add them. You can't add the 8 and the 5 and then leave, right? Because these two are different. So you have to implement the technique I showed you previously, where you gotta split this number into two other numbers, right? And this is the same number I've used the previous example, right? I split into these two, so this now becomes a 3, and this is a 3, right? So if I do it over here again, we have 5, right, plus 8, right? Now all you're gonna do is multiply these two, right? Just multiply it. 8 times 3 should be 24. And now that your square roots are the same, you can now add them. And the answer is 29 square root of 3. So yeah, nothing too complicated, hopefully. But yeah, this works for pretty much. Yeah, you could just use these strategies for kinds of problems that look like this. That's about it.